Okay, we're going to start talking about graphs of trig functions. Before we do that, we need to go over radian measure and angles again. So learn a little bit more about that. So today we're going to convert between degrees and radian measure and find the length of an arc and the area of a sector. Before we get too far into this, I want to talk about converting units. So let's say I have a speed of 3,000 feet per second, and I want to convert that. What is that in miles per hour? So we know that 3,000 feet per second, that means per 1 second. And in science, you do this a lot. You convert units. What you're going to do is multiply by a special form of 1. So I want to cancel out the feet, and I want to get it over here. I want it in miles. Okay, so can I go directly from feet to miles? Well, yes, but where do the feet go? I know that I need the feet to be on the bottom so that they cancel. In order to cancel units, you need one on the top, one on the bottom. So that's what we really need. So the feet have to go on the bottom. So that means miles are on top. Now, I know that 1 mile is equivalent to 5,280 feet. Now, I'm multiplying this by, really this is just 1, because 1 mile is 5,280 feet is also 1 mile. They're the same, it's 1 over 1. So I'm not really changing what this, the value, I'm just changing the units. So, but the nice thing is then the units cancel here. So now I have miles on the top, and I'm good here. Now what I need to do is convert seconds to hours, because I want miles per hour. So right now I have miles per second. Those are the units that are left. So I'm gonna have to multiply again so I can get rid of seconds. So now I'm gonna start, I need to go to seconds to hours. Well, I can't go there directly. You can, but I'm gonna go from seconds to minutes first. So I know that 60 seconds. Now notice I put seconds on the top because over here they're on the bottom. Okay, so in order for them to cancel, 1 on the top, 1 on the bottom. So 60 seconds is equivalent to 1 minute. So now my seconds are canceled. So now I'm in miles per minute. So I want miles per hour, right? So I'm gonna move this over just a little bit. Okay, and now I'm gonna multiply again. And I want to go, okay, minutes are going to have to be on the top now and hours on the bottom. I can go from 60 minutes is equivalent to 1 hour. Okay, so now my minute units cancel. And now I can just multiply across the top, multiply across the bottom, and that will give me my miles per hour. Now notice miles on top, hour, hour. Now, that's how it should work out if you do this correctly. Okay, so let's just figure out what we get. So I'm going to multiply 3,000 times 60 times 60 on the top. We'll do that on our calculator. Okay, 3,000 times 60 times 60. We get a big number. Looks like 10,800,000. Now on the bottom, I just have 5,280 times 1. So this is in miles per hour. Okay, so now what is it per 1 hour? So we're just going to divide these two up. I'm going to take that and divide by 5,280. Divided by 5,280. So this tells us our speed in miles per hour. So pretty fast, right? 2,045.5 miles per hour. Okay. So this is how we convert units, and this is a little more fancy one, but this happens in science a lot. Okay, so now today this is going to come in handy what we just did. So today we're going to be converting. Remember, radians we've already talked about. We looked at this. You know, the blue ones are radians, and they are generally written in terms of pi. They don't always have to be, but you'll notice some things that are equivalent. You know, like 60 degrees is equivalent to pi over 3. Some more common ones or easier ones might be 180 is equivalent to 1 pi, or 360 is equivalent to 2 pi. But really, any of these are equivalent, and you can use them just like 1 inch is or 12 inches is equal to 1 foot, things like that. These are equivalencies. So we can use those equivalencies to convert. So I'm going to stick with 180 degrees is equivalent to 1 pi, which we set up here, right? This one. That one is going to be just the easiest to kind of use. You can use any of these up here, but that's really the easiest one. So now just to figure out, you have to just figure out where does the 180 go? That's degrees. Where does the pi go? That's radians. So I'm really going to take 115 degrees. If I want to convert that to radians, I have 115 degrees. Remember, this is over 1, so if you want to put that over 1, you can. I'm just going to kind of keep that in mind. I know I need to cancel out my degrees, so the degrees have to go on the bottom because degrees are on the top here, okay? And so that means pi radians goes on top. So now degrees cancel, and I'm left with 115 pi over 180. Now, when we write it in radians, we want to leave it in terms of pi. So I don't want to type the pi in there. I just want to reduce this fraction right here, 115 over 180. So that's what I'm going to do on my calculator is I'm not going to type in the pi. I'm just going to reduce that fraction, 115 divided by 180. And then remember, you press math, enter a couple times, and that'll reduce it down for you. You get 23 over 36. And then we'll just write that pi back in there. So this is 23. Now put the pi back in there. 23 pi over 36. Now, radians. When you have the pi in there, though, it's assumed that that's radians. So if you don't write the radians in there, that's not the end of the world because it's assumed that that is. It's up to you. But this would be then my answer. Okay, again, in terms of pi. So how do I go the other way? Well, let's say I have negative 7 pi over 8. So now this is radians, and I kind of look at where the pi is to try to cancel that out. So I have, where does the pi have to go? Well, it's in the numerator here, so the pi radians has to go on the bottom here, and 180 degrees on the top. So let's see, the pi is going to cancel, the radians are going to cancel, and then I'm just left with, okay, this is negative, you're going to go 7 times 180 on the top, and then 8 on the bottom. So let's do that. Okay, I already know it's negative, but you could do that here if you want. If you want to put the negative in, I'm just going to already, so I get 1260 over 8. So I'm going to divide it by 8 right away. I get 157.5 degrees. So this was negative 1260 divided by 8 gives me negative 157.5, and then put my units on there, degrees. So that is the equivalent to negative 7 pi over 8 radians. So that's my answer right there. And that's how we convert. Okay. Sometimes it's helpful to kind of look on the unit circle and see if it's one that's already given to you. Like if it's 60 degrees here, you don't have to go through that work. You could just say, well, I already did that conversion, it's pi over 3. That doesn't happen very often, but it's always good to just check maybe your unit circle. So again, this is that's how it works. Hopefully this makes sense. We can just try a couple more here. I have negative 450 degrees. I'm going to multiply, where does the degrees go? It's going to go on the bottom now because they're in the top there. And pi radians right there. Okay, so then this gives me negative 450 pi over 180. So I just want to reduce that fraction. So I'm going to go to my calculator. 450 divided by 180, math. And there we go, 5 over 2. And I'll put the pi back in there. This is negative 5 pi over 2 radians. And again, you can write the radians in there or not. It's up to you. Okay, how about going back here, 11 pi over 3. Remember, it's assumed this is radians, so if you don't write the radians, that's okay. I just know that I need to cancel out that pi, so I'm going to put the pi on the bottom, 180 degrees on the top. These will cancel, the pi's. So I'll go 11 times 180 divided by 3. And you can write your answer right away if you want. Okay, I get 1980. And I'm going to divide that by 3. I get 660. So again, you can just write your answer right away or do this. So that was 660 and then put your degree symbol on there. And that's it. Okay, converting between degrees and radians, should be fluent at that. Okay, so now finding the length of an arc, we're going to use what we just learned. So length of an arc, that's S, okay. R you're already familiar with, this is radius. And theta is the angle, central angle, but it has to be in radians to use this formula. So that's important. So again, right, we're saying here's my radius. The length of the arc, let's just say I'm going from here, the length of maybe this arc to here. This would be S, that green arc. And then that would be my central angle. So if I want to know what that length of that green arc is, I need to know what the central angle is in radians and the radius. Okay, so here it says, given a central angle of 125 degrees, find the length of its intercepted arc, so that would be the green length there, in a circle with a radius of 7 centimeters, and then round to the nearest tenth. Okay, so the first thing is I need to know the angle is 125 degrees. That's not in radians. According to this formula, you got to put it into radians first. So I need to convert this. So I'm going to do that using the method we just talked about. So I would have 125 over 180. I'm going to reduce that. So I'm going to go to my calculator and go 125 divided by 180. Math. You get 25 over 36. So this would be 25 pi over 36. So that's what I'm going to use as my new theta, same as the degrees, but it has to be for this formula in that way, in radians. So now I'm just going to say my radius, they tell me is 7, and I'm going to multiply that by 25 pi over 36. And that will tell me how long the arc is. So let's do that. 7 times 25, and you want to use the pi button, so it's above it's the caret, so I'm going to do that, divided by 36, and see what you get. We're going to round this to the nearest tenth, so that would be 15.3, and then don't forget to put your units. It's a regular length So 15.3, in this case, centimeters. That's how long that arc would be. And that's how we find the length of an arc. All right. Area of a sector. Well, what is a sector again? A sector, let's say here's the middle. Let's say this is my radius. Okay, the sector is the area of that would be everything in this. This is a sector. Okay, that shaded region right there. So this is the same. It's still your radius. And once again, this is still your angle, central angle, but it does need to be in radians. Okay, so that's key. Now, find the area of the sector if the central angle is 3 pi over 7 radians and the radius is 11, round to the nearest tenth. Okay, so now this time, our angle is in radians already, so then we can just apply this and plug in and we're done. So 11 squared and then times 3 pi over 7 is my angle. So now if I just type it in just like that, then I should get my area of that sector. So let's do that. 1/2 times 11 squared times 3 pi over 7. So I like to keep, you can do 0.5, or if you don't want to keep doing fractions all the time, times 11 squared, and then times 3 pi over 7. We get 81.5. This will be 81.5 square centimeters. Since it's area, make sure you use square units. And that is how we find the area of a sector. Make sure you double check that your angle is in radians before you use either of these formulas. And that's it. You have an assignment on this. Write it in your plan book and check it off once you've turned it in. Good luck.